we're going to determine if the coordinates of this polygon is a right triangle. So essentially what we're doing is we're taking everything that we did last week and applying it to concepts that we've already talked about this year in the coordinate plane. So today we're going to talk about classifying triangles. We've already did that in Unit 2. We're going to relook at that again using the coordinate plane and skills that we talked about last week and that you did on your quiz. So if we want to determine if these points make a triangle or a right triangle, what should we probably do with those points? Graph them. Good. Let's plot them. 5, 6. 8, 5. And 2, -3. Okay, and then make sure you also label them. This was A, label this B, and C. Make sure you label your points.
We're just a car, you can't do the Pacific trip.
No, yeah, I know. Yeah. I'm here today. Save this for the seat. So, if we have a right triangle, what kind of angle does it have? Right angle. You have to show somehow that this triangle has a right angle. Well, what do we know about a certain type of line? These two type of lines intersect, right angle is formed. What do we call those?
What?
There's a type of line where two type of lines intersect and they form a right angle. What are they? Perpendicular. Good. So we have to determine that two of these lines are perpendicular. Well, we talked about perpendicular lines last week and on your quiz. What do we look at to determine if two lines are perpendicular? Look at their what? Their angles on your quiz. Their slope. Very good. We have to look at their slope. So we have to find the slopes of all three sides of this triangle to determine if we have two lines that are perpendicular, so we have a right angle. So pick any side, it doesn't matter.
Left side.
AB, AC, CB, which one we would find first?
A.
A what? AB. AB.
A.
We're going to find AB first. Now, you can use the slope formula totally fine. You're given a graph and a picture. We like to count for the slope. Okay, so we're going to count up. We went up how many? 1. We went up 1. And we went over
17. Just kidding. 4.
Well, 3. But we went to the left, so that 3 is
Negative.
negative. You can leave it like that. Positive over negative is a negative. So technically our slope is negative 1 over 3. You can leave it as 1 over 3.
Never did this.
It does. We flip-flopped it. Okay? So then, what other side do we want to find?
I mean, BC.
BC. Go ahead, count up and over. Find the slope of BC.
Okay, my pencil was not sharp.
And sharpen it really quick.
I thought I looked at it. It's so hot down because upstairs is so cold. That was hot down here.
Okay. So, what did we get for the slope of, we said BC? How far did you count down?
1, 2, 3, 4, 5, 6, 7, 8.
Yeah, we went down 8, but we went down, so the 8's going to be what? Negative. How far did we count over? 6. We went to the left 6, so it's going to be negative. Negative 8 over negative 6 simplifies down to what?
4/3.
4/3. Are these slopes perpendicular?
Nope.
Should we stop and say your answer is no?
No.
No. Yeah, those two sides aren't perpendicular, but these two sides might be perpendicular. So you still need to, if that happens, if the first slope slope you find and the second slope you find are not perpendicular, they're not flipped and opposite, don't just stop. You gotta find that third side. So now let's find the slope of AC. Okay, well, how far do we count up? How far do we count over? 3. Well, what does 9 over 3 simplify down to? 3 over 1. Are those two sides perpendicular? Yeah. If you look at these two slopes, are they flipped? Are they opposite sides? Yeah. They're opposite reciprocals. That means whenever you have that, you have perpendicular lines, which means where they intersect, a right angle is formed. So that is a right angle. Therefore, we have a right triangle. So your answer in this question would be yes. It is a right triangle. You have to explain your answer. You explain your answer, say something along the lines like perpendicular lines form right angle. Something along those lines. Therefore, it's a right triangle. Question. And when you're asked to determine if it's a right triangle, you just have to find the slopes to see if two of them are opposite reciprocals. None of them are opposite reciprocals, and it wouldn't be a right triangle. Question.
Yeah, so I tell them I can't do it. Principal say you can't do it. Tell them it's not good.
No, we'll leave you. Mr. Carpenter, we'll see the second. Determine if this polygon with these coordinates is a scalene right triangle. Well, we talked about in the last example how to determine if it's a right triangle. Right, it has one right angle. What do you know about scalene triangles?
All different sides.
All three sides are different. So again, we're going to take what you just did on your quiz and use that to find the distance of all three sides to show them that all three are different. So let's focus on what we just did. Let's just try to see if it's a right triangle. Then go ahead, plot point. 1, 1. 4, 5.
Where am I going?
And 4, 1. Now you might look at that and be like, well, duh, it's a right triangle. But that doesn't work. You have to show the math. You have to do the math to show that it's a right triangle. Yeah, but you have to do the slopes. So if it's quite obvious that I forgot to label the points that AC and BC form right angles, find the slopes of those. But you have to find the slope. And you have to. You just can't be like, oh yeah, it's a right triangle. Looks like it. You have to do the math to show it's a right triangle. You have to have your explanation. So we're guessing that BC and AC are a right angle. Let's just verify using the math. So find the slope of BC. How far did we count down?
1, 2, 3, 4, 5.
We went down 4. And we went down, so it's negative. How far did we count over? None. 0. What happens when we have 0 in the denominator? What do we call our slopes? Special. We're not allowed to have 0 in the denominator. To say is what?
0 slope.
No. Something like that. We're not allowed to have zeros in the bottom of fractions. Jessica? You remember? Yeah, very good. It's undefined. Perfect.
Undefined.
Whenever you have 0 in the bottom, it's undefined. Not allowed to have it. You can't divide anything by 0. So let's find the slope of AC. Okay, well. How far do we go up? Go from A to C. 0. We don't go up at all.
Undefined.
Not so fast. How far do we go over? 0. Some of you might be thinking, what the heck? Well, they're opposite reciprocals. Whenever you get undefined in 0, they are opposite reciprocals. Okay? Because look at those fractions. Here, you have 0 in the bottom. When you flip it, 0's in the top. Doesn't matter that these aren't the same. That's okay. So whenever you have undefined in 0, they're opposite reciprocals. Every time.
Oh, what's that mean?
Well, if we have opposite reciprocals, they're flipped and opposite of each other. Do we have perpendicular lines?
Mm-hmm.
Do we have a right angle? Yes. So is this a right triangle?
Yes.
Yes. So again, undefined in 0 are opposite reciprocals. So we know we have a right triangle. And again, our reason perpendicular lines form a right angle. So we have a right triangle. So you need some sort of explanation to say that there's a right angle. So we just showed that it's a right triangle. We now have to show that it's a scalene triangle. So we have to find the distance of all 3 sides. How do we find distance? What do we use? You can use the distance formula, but we're not going to do that. You can. I'm not going to show you that.
Oh,
What did most of you use?
Pythagorean theorem.
Yeah. Adriana, and I know you are right. A squared plus b squared equals c squared. That's what we're going to do. Now, it's nice when you have lines that are perfectly up and down and perfectly horizontal. Non-slanted lines and sides I love because you just count. Find the distance. You don't have to do any Pythagorean theorem. None of that silliness. You just count. So we already kind of did this, but what's the distance of BC? How many units do you count?
-4.
Don't worry about the signs with distance. It's just 4. Okay? We'll do the same thing with AC.
I'm not in my room.
How far is AC?
3.
3. So far, so good. If you had 4 and 4, we could stop because 2 sides are the same. But we can keep going. Let's see when we're different. Now here's the thing. We try to find AB. AB is slanted. So you just can't count. Okay? This is, again, when you're trying to find the distance of slanted sides, you just use your Pythagorean theorem. So you make your right triangle. What's the distance of this side? 4. So
I can't
4.
wait to do the other side.
You can recognize that that's already a right triangle and use those as your legs. That's totally fine. That's not always going to happen. You'll see in the other one, all the sides will be slanted. So just review. So that's 4. So we have 4 squared plus, what's the distance of this side? 3. Equals c squared. This side, always our c. And we're just plugging it into this formula. And then clean it up. 4 squared? 16. 3 squared is 16 plus 9 is 25. What do we have to do to both sides? Square root. So c is equal to what? 5. You could have recognized that this was a what? Pythagorean triple. If you do that, you save yourself so much time. If not, no big deal. Just do the Pythagorean theorem. So this side's 5, this side's 3, and this side is 4.
What if you're wrong? If you don't.
Recognize that it's a P-trap? Then you just double check your work, just in case if you're unsure. So can we say that this is scalene?
Yeah.
Yeah. Yeah, scalene triangle. All 3 sides are different. Just need something along those lines. All 3 sides are not the same. All 3 sides are different. Something along those lines. You need some form of explanation with your answer. Questions over that?
Okay, we're done.
We get ready for similar to the last one, we want to determine if this is a right isosceles triangle. Alright, well, let's see if it's isosceles. Right first. How to do that. Which angle looks like the right angle? C. So let's try to see if that one is it first. So which segment do we want to find the slope of? CB. Find the slope of CB first. So how far do we count up? How far do we count over? 4. So that's the slope of
4.
CB. And don't get distance and slope mixed up, because you kind of count them the same, but slope and distance are two different things. Okay? Slope you write as a fraction. Distance you're using the Pythagorean theorem. Slope you're finding the slant. Distance you're finding how long something is. So they're two completely different things. Similar steps though. Similar counting methods. So then, let's find the slope of AC. We think that's our right angle. Well, how far do we count down? 4. So we went down 4, so this is going to be what? How far do we count over? 3. We went to the right, so it's positive. Are they flipped?
Perpendicular.
Are they opposite? Yes. Are they so, are these perpendicular? We know we have a right triangle. We know this angle is a right angle. Yes. Right triangle. Perpendicular lines form right angle. Some sort of explanation. Doesn't need to be a paragraph. It's a little word. Why not? Right? So now we just showed it was a right triangle. Let's show its isosceles. So what do we know about isosceles triangles?
The same.
Alex? Good. Two sides are the same. Well, let's try to see. Here's the thing. With right triangles, you obviously know that once you show that two sides are the same, the other third one can't be the same because then it wouldn't be a right triangle. But for the sake of just practice, if you're asked to find if a triangle is isosceles, you have to find the distance of all three sides. Because if two sides are the same, that third one might also be the same because it could be equilateral. So make sure you're finding the distance of all three sides when you're asked if something is isosceles. Because it could be equilateral. So which side do we want to find first? CB, AC, or AB? Look at AB. AB. For the sake of the problem, we're going to help you out. Let's not find AB first. Okay, we'll find AC. So we're going to find the distance of AC, and again, what do we use to find distance? Pythagorean theorem. After you're told to find distance, we're just using the Pythagorean theorem. We're finding the segment. Make your right triangle. What's this part right here? How long? 3. We already counted it, but you might need to recount. That's 3. What's this part? 4. Plug those in. And again, this is always our C. We have 3 squared plus 4 squared equals C squared. What's 3 squared? What's 4 squared?
It's the same letter.
9 plus 16? 25. What do we have to do to both sides? Again, you could have recognized that this is a teacher, but you wouldn't know your answer right away.
Oh, wow.
So C equals 5. Alright? Well, let's find distance of DC is Yep, you are correct. Because you notice we have this triangle. Again, we're going to find the distance of BC. Well, when you make your right triangle, what do you notice about the legs?
They're the same.
They're the same, right? This side's 3, so when you plug in Pythagorean theorem, it'd be 3 squared. That side's 4, so it'd be 4 squared. What do you notice about here and here?
It's the same
It's
thing.
the same thing. So do we have to do any more math?
Hey, guess what? It's a picture.
No, you know it's a picture. We don't have to do more math to find it. When this happens, you get the same exact numbers in your Pythagorean theorem. You don't have to do any more work. You get the same answer. You can just say C is equal to 5. Same exact numbers, you're going to get the same exact answer. Save yourself some time. That's totally allowed. You know what the answer is going to be. So far so good. We have two sides that are the same. Let's find A and B. Yep. You just for the sake of practice, if we didn't know if it was right, if it just said find, see if it's isosceles, it could be trying to trick you and be equal out. So to find the distance of all circles.
So 5 squared plus 5 squared, right?
Here's our triangle for AB. You can use that.
Because we already got like the other sides to the triangle. I don't want to choose.
We only have 2.
I know, but you know how it's 4, 3, 5? And they're both 4, 3, 5.
Distance. You don't know that this is 5. You know this is 5, this is 5. We don't know that that's 5.
Yeah, can we just like do A squared plus B squared plus 5 squared plus 5 squared equals C squared?
You can do that. Yeah. You can do that. We get the same answer. So just for practice. Alright, so what is the leg of this one?
1, 2, 7.
Good. This is 7. What's this guy? 1. So we plug in the Pythagorean theorem. It's going to be 7 squared plus 1 squared equals C squared. What's 7 squared? 1 squared is just... What's 49 plus 1? 50. What do we have to do to both sides? Yeah, you don't even have to worry about simplifying that radical, because it's the square root of 55. No, square root of 50 does not equal 5. So can we say this is isosceles? Yeah, only 2 sides are the same. Only 2 sides are the same. That's what this whole unit is. It's taking what we've done all year so far, applying it to the coordinate plane. Using what we did last week. Distance, slopes of perpendicular and parallel lines. Okay? Questions over there?
I didn't